There's nobody on. Okay.
Oh, now we're having people start. Sure thing.
Yep, ready.
Yep. Good morning, good afternoon, or good evening, everyone, depending upon where you happen to be in the world today. Welcome to this month's Egeria Metadata virtual roadshow event, webinar here. I imagine a number of you joined last month where we had a number of talks, and we're continuing that on with some monthly webinars of different topics within the data governance and metadata space, and how that intertwines with Egeria. This month, we have a great talk from Mandy Chessel, who is the project lead and the TSC chairperson for ODPI, on building a data catalog. Just before we get started, we hand it over to Mandy. Just a few housekeeping notes. If you have any questions during the session, you can use the Q&A chat box, and we will monitor that. We have myself and Chris Blum in the background who are monitoring all open QA, and you can ask questions throughout. We will try to hold most of our answers till the end, although if something is very prudent for a particular slide, we might raise that up to Mandy and she could interject it there. But in general, we'll keep all the questions at the end, but please, as you're going through here, if you have any questions, please raise them. And if there's any technical issues that you're noticing during today's session, please, you can ping either through the Q&A or ping myself, John Mertic, or Chris Blum directly, and we will look to address them. With no further ado, turning it over to Mandy.
Thank you very much. So today's topic is something that's very popular with so many different technologies that are offering the idea of a data catalog. And so I'm going to talk a little bit about the content of a catalog and how to manage it. The discussions, it's always easier to do this sort of thing in a context. So I'm going to use some characters from our Coco Pharmaceuticals company. Now, this is a fictitious company, but it has I don't know, about 20 different personas in it, and these are all people who actually the personas were built from real people in real situations, but obviously by using the persona names we're hiding details of specific companies and individuals. So the things I'm going to show you are actually based on things that are very common in many organizations. So we're going to bring in some of these people as we go through the presentation. Now, the title of the webinar was Building a Data Catalog, because that's quite a common name used in the industry. But actually, really, whenever you're doing any type of management or governance, you're collecting information about the things you want to protect, the thing you want to manage, locate, search for, etc. And in general, we call those assets. So the origin of Egeria was really around supporting data-oriented users such as data scientists and data engineers, locating different sources of data. But in reality, the more you look at the types of capabilities that Egeria is delivering, you start to realize that actually it isn't just data that a metadata management system can handle. There are lots of different types of assets. So often we talk about this idea of an asset catalog. And the interesting thing is that assets are not sort of unique, unconnected things. They build on one another. So if we think about the broadest definition of an asset, which is something you want to manage, you can start thinking about the infrastructure, such as the hosts and the servers and the platforms that the servers are sitting on. And this might be both the hardware and the software, which is a changing boundary in today's world. And these are the sorts of things that configuration management systems, and if you're using the ITIL governance standard, that's really what we're talking about here, configuration management, CMDB. There are processes, and you might need to catalog the processes that you're using. They might be governance processes, they might be business processes, but they might be needed to be managed because they help people find out how to do things, but also may be part of the regulatory requirements of the business. And they, of course, run on the infrastructure. And then we've got data in its different guises. So data store is data that's being stored on a disk, for example, and data in motion is really data that's being fed across the network to the organization or the process or whatever's consuming it. And both of those sources of data effectively can be used to make decisions, and so they become a part of the organization's assets. And they're obviously consumed by the different processes. Then we have a business view of data, a collection of useful data, and we call this a data set. And data sets generally think of those as queries on different data sources, such as the stores and the feeds. And so these are the things that the business sort of starts to use. So if you look at the hierarchy here, you can see physical things like the data stores could be a folder on a disk, whereas something like a form or a report, which is something that's generated in software, but is a collection of data that a user uses. That's what we mean by a data set. And then we've got APIs, which are another way that both function and data is made available. And then software, so we need to think about the software development lifecycle. So there's a lot of talk both in the software, in the sort of software development aspect, and in AI delivery and development, about creating that DevOps life cycle between the way that analytic models and software components are brought together, sort of taken from the development environments, from the data scientists and the developers, brought together, deployed into production in a continuous delivery cycle, and sort of bringing that together. So these assets also become an important part of Egeria. And when you start bringing these together and linking them together in a catalogue, you're able to cross boundaries of knowledge between different groups that make it incredibly valuable and useful in solving regulations. So if you look at something like GDPR, which is the European privacy regulation, that is talking about things across many different governance boundaries, from securing the infrastructure, managing threats to the data, user interaction, the way that software is designed with data minimalization. And these, as I say, typically managed by quite different tools and quite different organizations, which is why pulling these together in Egeria and allowing the exchange and linkage of all this data becomes so valuable. Okay, so at the top of this thing is the thing called the asset, and everything else is inheriting from it, which means that it's basically adding additional information and relationships underneath it. And the basic asset has very, very few properties to it, which is really just trying to identify it and providing as minimal information to identify it. And that's because that for many tools, they're not supporting a full governance life cycle. They're just really just trying to document that there is a thing, an asset that they know about, and so that's why this is a very simple definition. So it's a unique identifier that is unique across Egeria, a qualified name which is unique within the asset, a display name because these qualified names are long and unappealing, descriptions, and then any other properties that help us to understand it. So we know what type it is, and we have basic information. And so if this was all we did, you would be able to search assets based on its type. But if you imagine searching for, you're looking for data of a particular type, you'd know about the fact that there were databases, but you wouldn't really know what was inside it. So we want to add a lot more information to this core asset definition and link it in. And this will come in through lots of different processes so that we have more information to help with the searching. So the first thing we often add is what's called a connection. And this describes how to connect to the asset and access its contents. And when we have that connection information, it means that we can do a lot of automated processing on the internals of the asset. For example, we might profile it or validate its quality or provide access to the data for different tools, so people can search, find some data in the tool, and then open it up through the connector that's generated from the connection. The connections are very important. However, we don't necessarily put a connection on every asset. We put it on assets that that we think are interesting for people to connect to. So here we've got a file system with a series of different assets defined, folders and files within it. But you can see there's a folder, data folder there that's got a connection to it because all the contents of that folder is like a data set. It's a set of useful information where maybe each record is a different file, but we want it to be used as a group. Whereas further down, there's 2 data files there, and each of those are independent assets, and so they have their own connection. So anybody searching through the catalogue can see which things are worth accessing through the availability of the connection, which of course allows you to then create the connector. And the connector is like a client that allows you to access the content of the asset as well as everything Egeria knows about that asset as well. So the interface that the connector offers is pretty much will tell you about the asset and then everything that's connected to it, which I'm going to cover in the next few minutes. So that's the connection. Then we might want to know about how any information inside it or any operations are structured, and that's called a schema. So the schema describes the organization of the data and the operations that the asset supports. And so you can start to see what would be in there. So for example, a database has a schema that describes tables and columns. You might have a graph that describes the different nodes and the relationships between them. Tables have, you'll find out about the columns. Documents have a sort of nested hierarchy. So all of these different types of schema structures are supported. And they can either be entered by the person that's cataloging the asset, or they can be sort of derived or discovered through different processes that we'll talk about in a little while. Okay, so that's the schema. So that's the structure. So we've got the ability to access it through the connection, the ability to understand how it's organized. Then we can define who the owner is. And this is very good to actually start creating a conversation between the people who are using an asset and the owner. And the owner is typically responsible for making sure that the catalog entry for the asset is actually correct. And we can have asset owners that are just user IDs, or there's a proper profile, describing who the person is, or a team. So you might have some assets that are big and important, and you actually might have a team associated with them. Then we got some questions. Oh, that's okay. Okay, so that's the owner. Next are zones. So zones allow us to group assets together that have a similar purpose. So we might have assets that are representing raw data that for the data scientists to work with in building models for deploying into existing systems. And then we might have a different zone that has assets that are simplified, consolidated, aggregated data for more business users to work in spreadsheets or different types of more simple analytics tools. So we use the zones to break up all the different types of assets that we have, to group them together. You might have another another zone that has assets that need archiving, for example. So we can use the zones for not only for what people see, but also what automated processes see as they're working with the metadata. Next, it's very useful to know where assets are. This can be important where data is sensitive and should not leave a certain region, or a physical asset should not leave a certain location. And we can model physical locations, digital locations. We can create hierarchies of different locations so we can understand things at more coarse or fine-grained granularity. So there's quite a complex, sophisticated model that we have around location for our assets. There are external identifiers. So basically the assets might be represented in lots of different tools and have a different name identifier in these different tools. And if we can catalog all the different identifiers that a particular asset has, then people can search on the identifier that they're used to, and then they'll find the asset according to the ID that they're used to finding, rather than having to remember, oh, in Egeria it's called Fred, and in my tool it's called Tom, or whatever. So this is incredibly useful at making the asset file more findable through these external identifiers. Next, we have to accept that nowadays not all data, not all assets come from the organization that's using it. And so the asset might have a license associated with it, which provide the sort of terms and conditions under which the asset can be used, distributed, and the conditions under which it needs to be deleted. So it might be available for a month, for example. And by having the license attached, it means that people are much more aware of how the asset can be used. Certifications are sometimes very formal. They're part of a particular legal regulation, or they might be something that's defined in the DevOps definition, some sort of quality gate. And so by seeing the certifications, you can say, okay, I know this particular asset has reached a certain level of quality or has passed a certification for regulation. And that might affect when it can be used and people's confidence in using it. Next, we want to put labels on the asset to allow us to find, again, to help find it. And the different types of classifiers we have provide different levels of formality in terms of the labeling. So there's a thing called an informal tag, and this is a social media tag that anybody can add to the asset. The informal tag can be reused by other people or can be private to an individual. Although beyond the sort of personal search, it's not so useful. It's much better when the tag is public. So the informal tag is basically any user. Whereas the owner can add things like the glossary terms, which are formal definitions, reference values, which is like sort of lists of valid values. So if you wanted to sort of have a set of classifiers that, for example, for Coco Pharmaceuticals, maybe they have a set of classifiers for all the different types of images they might get from the different machines that are measuring the patients and their recovery. So there's the reference value, and then governance classifications are very traditional type classifications, such as the confidentiality of the asset. So is this a sensitive piece of data, for example? So lots of different ways and different sets of labeling that are more or less formal that can help provide the thing that you can search on to actually locate the asset that you care about. Now, the interesting thing is that we could just classify assets, but actually most of the things that we're attaching to assets are of a type referenceable. An asset is of type referenceable. So these classifiers actually they can attach to anything, which means we can assign a glossary term to a field in the schema. And we can say, so this field means this certain value. and we could classify a connection to say this is the important connection, or this is the connection used by consumers or whatever. So lots of different ways that we can provide additional labeling and insight into all parts of the asset definition. Another thing is informal feedback. So nothing better than feedback from people who are using the assets. So you might have a data scientist going, hey, look what I've done with this particular data set. I've got this amazing model coming out. This data is really, really valuable. Or it might be, I'm very suspicious about the quality of this data. This doesn't seem to make any sense, for example. And then the comments can be different conversations, so people coming backwards and forwards, replying to particular comments. And there can be sort of independent comments as well. So these comments are very flexible conversations you can have. You can add likes, ratings, and reviews to the assets as well. And because Egeria itself is GDPR enabled, all of these feedback by default are private. And then the user is able to actually sort of switch a flag on and say, actually, I want this public and shared. So their comments by default, they basically have to give permission for it to be shared. Okay, feedback. Next we have note logs, which I should have called blogs really. They are lists of notes that the asset owner can add to the asset. And you could think of it as a set of notices to say, oh, by the way, there's going to be an outage on this asset, or there was an error loading data into this asset, and it will not contain the full set of values from the day before until midday, for example. So the owner can actually talk about the maintenance and the things that are going on the asset through this. So this is more of a publishing one-way conversation, unlike the comments, which were more of a sort of a two-way interchange. This is more of a broadcast publishing type attachment. Okay, good. External descriptions. Now, of course, much as we'd like to put everything into Egeria, or all the tools that are connected via Egeria, there will be document libraries and web pages and other types of media that would augment the description of the asset. Maybe it's a picture of its internals, its design, or whatever. So we can either put URL links to other references, or actually link to the media itself, such as the a video or something that describes how to maintain the asset or something. So again, we can create a very rich definition, which is nice for people who are browsing the catalogue and things like that. The next topic is something that is always very popular, is something called Lineage, which says, where did this asset come from? And the thing that makes this quite complex, and that's why this is quite a busy chart, is that people's definition of what they mean when they say lineage varies depending on their background. So sometimes people just want to know that this asset is hosted in this component. So this came from the data warehouse, or this came from the data lake. Or it might be that you want to actually know that it came originally from a system and the data has now been copied and transformed 10 times before it got to me. So the actual original source, absolute original source, they might want to go right back, and they might want to know the detailed process, or actually what we call the supply chain, which is the sort of flow of data between systems for a particular type of data. So depending on the end user, you might want a very high-level business-oriented concept of where something came from, or they actually need to know the technical components that created, the file or whatever the asset is. And so what we have associated with the asset is all these different levels of granularity of information. And so, for example, if we look at something like the supply chain, the information supply chain, from that high level picture, And by comparing supply chains for different assets, we can start to understand why what looks like two reports which seem to be providing the same information actually have different values, because they may or may not include as many sources of information as the other. So that's really why we look at this this thing called the supply chain to really to make it comprehensible to humans in terms of where the data is coming from and what to expect from those values. So that's the supply chain. And then the final thing is that, as I said before, there are many types of assets and they're all related to one another. So we might know that a data store is actually hosted on a particular machine, and the following data set is deriving its data from a particular data store. So lots of different relationships between assets, and so they are also available or accessible through the catalogue. So I've covered lots of different types of information, and which is summarised here, and I'm hoping what you're getting the feeling is that what we're trying to do is to create as many entry points into the catalogue to help people find the assets based on their particular perspective. And for some, you know, it's a glossary term that will take them in, and for others it may be a particular zone or who owns it or whatever. You know, you might just know something and be able to sort of locate the asset based on that information. So locating assets is key, but it also helps individuals who are consuming the assets to make sure that they understand how the asset can be used. So that means you can have assets that come from other companies or other organizations, and the knowledge about the terms and conditions associated with it, for example, are not lost. And we also can show, we also can then understand which assets is sort of an impact analysis type view, where we might look at an asset and say, okay, if this asset went away, what breaks? And so this other linkage also helps with that type of analysis. We can see sort of maybe understand an organization's risk. So how many of our assets are on this server or on this cloud system or in this location? How many assets of a certain type of data have we got in our organization, and whereabouts are they? So all of these questions start to help the organization manage their risk associated with the assets. And then probably for today's world, what is also critically important is that there's too much data, there's too many assets, there's too much complexity in our IT systems today for humans to keep that in their head and to manage it manually. So we need to enable and encode information about all of the assets, no matter what type they are, so that automation can operate in a way that not only is reliable, but also is auditable. And is not a massive maintenance nightmare. So the classifiers, for example, are very good ways of allowing the owner to change the classifier, and then the underlying automation uses the classifier to control its behavior. So it's a lot of opportunities to save money and improve the management of these assets through this type of encoding. So I've got a question here, which is a good one actually, how flexible and rich is the version management of the assets? So we have, the answer is very actually. So we can version the types. So it's possible to extend and add new properties. Each asset and linkage and attachment is individually versioned. And this is critical when we're sending content across the network and between tools, because messages can get swapped around in a complex network. And so the version number is critical to make sure that we don't apply a back level version on top of the latest version. So pretty much everything is versioned, yeah, from the types, the protocols, and the asset instances themselves. Well, I would say every element here: relationships, assets, so the entities and the classifications. Okay, so what I've covered so far is, so next question is, how can Egeria be integrated with Apache Atlas? So Egeria is, you think of this as a big integration bus, and it provides different frameworks and connector interfaces to connect different types of technology. And so Apache Atlas, we have implemented at what we call a repository connector and event mapper for Apache Atlas, which is available on the ODPI site. So you can run that in the Egeria ecosystem, and then we are able to exchange Apache Atlas metadata with other tools through that connector. So that's Apache Atlas.
I have a couple questions here, Mandy.
I'm sorry?
I have a couple questions here.
Okay.
The first one, how flexible and rich is the version management of the assets?
Oh, okay. Sorry, I'd done that one earlier on. Sorry, I was reading them. I've got them up here, and I was covering up. So basically, I was saying is that the version management of the assets is both on the type and on the instance, and each element is separately versioned, as well as the relationships between them. So that was the version management piece.
Awesome, thank you.
And then the other one was the Apache Atlas integration, and that again, we have a specialized connector that allows Apache Atlas to connect into the open metadata ecosystem. Okay, so that's those pieces. So what I've covered so far is what is inside the asset catalog. Now I'm going to talk about how we actually make the catalog work. And I've talked about, you can imagine that if somebody was manually cataloging all the assets of the organization, it could be a life's work, and somewhat thankless as well. So what's absolutely critical is that there are some things that require a human expert to actually set things up, and then automation can kick off and make use of that information. There are other things that actually automated processes are far better at when it comes to actually accurately creating content for the catalog. So I'm going to talk about the different options that we have and how they can be blended. So I'm going to talk about mechanisms first, and then go into some examples showing Coco Pharmaceuticals in action. Okay, so we have 4 choices basically. The very first one is a tool with somebody sitting at the keyboard typing things in, right? So we call this manual. And there are cases where you do use human subject matter experts to actually catalog stuff. But as I say, as the volume goes up and the frequency of this happening, and people are just not very good at that sort of thing. So we use manual cataloging only really when it's the subject matter expert needs to choose different options, for example, around adding classifiers, typically done by people. Templated is when we've set up, maybe we get a new asset of a certain type every week, and it's boring to do the 10 different attachments to create the catalog entry. So you can just say, could you catalog this asset following the pattern established by this asset, so like this one. And so basically an existing asset or a special templated asset can be used to actually set up a new asset coming in. And so that turns, sort of 10 different steps into a single one that is reliably making sure all the attachments happen. The next one is integrated. And so this is where we have one of our servers called an integration daemon that is connecting to the server where the assets are sitting and having a sort of two-way conversation, looking at what's in open metadata and what's available through the server about the assets, and maintaining consistency between the two. So it might be taking content from open metadata and pushing it into the server, or reading what's going on in the server and taking that content and pushing it into open metadata. Or it might be listening to events from the server. So there's different patterns and different capability, but it is limited to the metadata that the server supports. So if the server's, say, in a database server, through this process, we can pull the fact that a new schema has been added to the database, or a table's been added, or a column's been deleted, and we can maintain that, what we call that technical metadata, through the integration daemon. So we can capture everything that's available, but only what is available in the server itself. So that's integrated. And then the final one is discovery and stewardship, and this is where different types of analysis techniques can be plugged into what we have called our discovery server. So anybody can write standardized discovery services. They plug into the discovery server, and they can do different types of analytical processes to look inside the assets and create new metadata about them. And so this is again why that connection object is very useful, because the discovery service can use the connection object to create a connector, and that's how they link in and can access the asset. So this allows us to generate brand new insights about the open metadata. And it may be, you can see that over the other side is the stewardship server. It might be that the discovery service comes up with a few alternatives. So I think the content of this data is either information about a customer, or maybe a prospect. So not actually somebody who's bought anything. And then a subject matter expert might use that shortlist and then make a choice as to what's been done. So it doesn't eliminate the use of the subject matter expert, but it greatly reduces their work by coming up with a short list of suggestions. Or the discovery service, it might be so accurate that it just goes straight into the catalogue directly. So we have these four methods. So I'll now cover how we just some examples, so you can get you can be a bit more concrete about this. So I'm going to start with Peter. Now Peter's an information analyst, and he is responsible for cataloguing the weekly patient readings for the clinical trial. So this is coming in through FTP. He picks up the files and brings them into the catalogue, and then the data scientists will see that it's in the catalogue, and they know that they can start working on the information. So, you know, there are a number of things he has to set up. He has to set up the connection, define the schema, add the license information, the zones, and the owner. So, you know, the first week he does all that, and that's really good. And then the next week he gets to do it all over again, and the following week all over again. So, you know, he's a busy person, and this could be quite error prone if he's doing this all the time. So this is sort of the use of manual. You know, it works if we could put this into a script, so he doesn't have to manually do each step. But what would be better is, rather than the script being outside or in Peter's head, is actually to use this templated. So it's where he basically says, catalog this asset using, catalog week 2 using the week 1 asset. And that's fine, unless there's sort of things that you don't want, that week 1 might have a series of comments in it. So you could actually create at the beginning of the project a template for a particular asset type, and then use that template each week to catalogue the assets. So this is particularly where you're using quite a rich asset property. Then it's very it's really a very valuable technique. Simple, but valuable. And the template can be maintained over time as well. So that's a templated. Here's an example of the integrated cataloging. So Callie's a data scientist, And she has a database, and when she's doing experiments, particularly with relational data, she creates a new schema in that database, which she calls a sandbox. And she does her experiments, and sometimes she remembers to delete it, sometimes she doesn't. What we've got here is this data platform proxy, which is an integration daemon. It's constantly monitoring the schemas in Cali's database and cataloging them in the catalog. Now this means that Cali's got a record of all her sandboxes. It also means that, for example, there could be an automated process that is removing sandboxes that are not, say, associated with a project, or that seem to have been abandoned. And so Cali can do things in the catalog to maintain a sandbox for a longer period of time, or just let it be deleted, if it's something that she doesn't need to keep. So again, very, very simple, but it means that Cali doesn't have to manually catalog this. And again, the proxy might be using a template as well. So again, what's coming out of this could be actually quite a rich content. So that's integrated. And then the final one is the discovery and the stewardship. So as I say, the discovery server is running discovery services, and they are creating a whole series of what we call annotations that are all the findings that they've had from analyzing the content. And then when the discovery service completes, the discovery analysis report that it's created with all the annotations hanging off of it is then marked complete, and that causes a notification to go to the stewardship server. The stewardship server evaluates the annotations and may automatically say, yep, that's ready to be attached to the asset. Or maybe a steward is involved in terms of confirming some of the findings of the discovery server. And so this way, for example, as the new asset comes in, the discovery service kicks off, and by the time Cali gets to look at the asset, there's a whole series of profiling information that tells her the average values and various other things that are in that data as it comes in. So her work is greatly reduced by this automation here. Okay, so that's discovery and stewardship. And we talked a little bit about Peter, who's doing the sort of manual cataloging, or he's trying to manage the catalog of the data lake, and Cali, who's a sort of data scientist. So I thought I'd talk a little bit about other people. So this one, firstly, is Cali, where she's getting her, we talked about her own sandboxes being automatically catalogued, but also when she's searching for data for a new project, she gets a huge amount of information that has come from all these different pieces of information that have been attached to the asset. So she gets a pretty good view of what, of what is actually available to her, and so she can act responsibly with the data that she's using. Then when we start looking at other types of users, so here we've got the Chief Data Officer, Jules, and he needs to be able to monitor how successful they are being at transforming, becoming much more data oriented. And so he can look at the asset catalog and see how the assets are being used, the conversations that are going on, all the different sort of comments and things that are going backwards and forwards, how much the assets are being linked to different projects and other things within the metadata catalog, to get a feeling for, and the quality reports as well from the discovery service. So he starts to get a knowledge base to see how well his strategy and governance program is actually working. Faith Broker, she is interested in privacy and also personal data. And so she can start to look at the risks associated with the distribution of personal data across the organization. And also look at the interactions and usage of the metadata from the different employees. And so she's got two hats really, and but mostly her focus is on the privacy and protection of the personal data in their systems. Gary Geek, he is in charge of the IT infrastructure, so he normally would manage details of all the IT systems in a spreadsheet. As Egeria comes in, he is now able to not only document all the servers and the levels of software and things like that, but he can start to see, you know, the software, the sort of systems he's put on. He can start to see the assets that are being deployed by different teams into his infrastructure. That links up to the business usage and other types of things. So now he gets a much clearer view on how the infrastructure is being used, and if there's an outage, for example, which bit's critical, and his ability to plan for the future is far greater because he's now got a huge amount of business context sitting on top of the infrastructure assets. Next, we got the clinical trials administrator, Tanya. So she has support because she now has a catalogue behind her work. She can have used the discovery service to make sure that there's a lot of quality running over the records, and she can control who can access the patient records and things. So she feels that she's much more in control of the environment now. Now she's got a catalogue. The security officer, Ivor Padlock, he's he again is interested in understanding risk, understanding where things are and where particular types of protection is needed. So understand, as I say, having that layered view of the ecosystem is very important. And there are different security capabilities that can be set up based on usage and knowledge of the content of data that can be controlled through the asset catalogue. So really what we've been showing is that catalogue could just be a list of assets, but as you start to add add more information coming from different types of subject matter experts to the assets, then the assets become much more findable. But automation both makes the catalogue richer, but also increases the value that the organization gets from the catalogue. So open APIs, distributed metadata that can go into different tools really allows an organization to start to become much more coherent in the way that they build new systems, the way they operate the business, and the way the different types of governance teams work together to create that efficient and safe environment for everyone involved. So that's, I think that's it. Yes, so we have a little bit of time for questions.
I think we've answered the two we have. If anybody else has any questions, feel free to type it into the Q&A box.
Yeah.
Oh, we've got some. Those we answered already.
Excellent. Yeah. And I understand someone asked about the recording, and I believe this is all being recorded, and the charts will be available as well.
It is being recorded, and we will get it up on our YouTube channel later this week.
Mm-hmm. Yeah. And this information is also on the Egeria website, so you can see. Let's go to here. If you actually, there's a GitHub link here, and at the top of that page, there's a link to our homepage, and you'll be able to see there's a section called Building a Data Catalog. And so much of this information is linked off of that particular guide.
Okay. I don't see any other questions. We will be doing another webcast at the end of next month on the last Tuesday. We will get more information out about that this week to everybody. Anything else you want to add, Andy?
No, just thanks everybody for listening, and I hope it was enjoyable.
Oh, wait, one just came in. Let's see. What about the life cycle management around the system?
Which system and which life cycle, I suppose. So this is really an ecosystem of lots of different tools, and the tools can come and go from the ecosystem, and their content is shared. There are so many life cycles going on. So there's the life cycle associated with a particular asset as it's onboarded, is maintained, and eventually decommissioned. There's life cycles associated with governance programs, software components, and the systems that are hosting the assets. So what we do is one of the reasons that the model is actually a graph that allows different tools and different life cycles to contribute content is precisely because there isn't a single life cycle. There are many life cycles, and from each community of users who are sort of maybe a particular type of professional, they have their life cycle and they expect the metadata to work around them, but they're providing useful content that will actually inform a different life cycle. So that's why I have these sort of spinning pictures here with the metadata in the middle, and they're all spinning at different speeds, and there's actually lots of them going on. And so this is actually the complexity of what we're trying to help with is the huge number of life cycles.
Thank you. We answered that one. Okay, I think that's it. Well, thank you so much for this awesome presentation, Mandy. And thank you, everybody, for joining us. We are recording this, and it will be posted up onto YouTube. Have a great day.
Thank you.